Okay, in the previous session, we had discussed the topic related to data types. Simply, data type specify the type of information stored in a variable. For example, integer data type, it will store all the whole numbers. And the integers are categorized into different things. So one is decimal number, binary number, octal number, and hexadecimal number. If any number contains a combination of digits 0 to 9, any number contains a combination of digits 0 to 9, such type of numbers are called decimal numbers. And octal, in the sense, octal is called numbers are allowed. If you are starting from 0, that is ended 7, that is the total of 8 numbers. If any number can contains the digits from 0 to 7, such numbers are called octal numbers. And which contains the values from 0 to 15, those are called hexadecimal numbers. Those are called hexadecimal numbers. Now the main important and one more thing is any numbers contains 0 and 1. Those are called binary numbers. Now, how do you differentiate among these numbers? For example, consider 5. 5 is a decimal number that is in the range 0 to 9. In the range 0 to 7. 5 is hexadecimal number in the range 0 to 15. So differentiate among the numbers, by default, every number is considered as a decimal number. If any number prefixed with the keyword 0, 0, such numbers are keyword 0x, that is called hexadecimal number. If any number prefixed with the keyword 0b, so that is called binary number. This is the way we are providing the differentiation among the numbers. And after that, we have three important functions to convert from one format to another format. Suppose one function is bin of, that is bin of. So bin of used any convert any number into binary format. What output is the binary, octave output is octal, hexaf output is hexadecimal format. So those are different types of numbers under integer format. Next one, coming to floating point number, also called as real numbers. Real numbers, compulsory a floating point number must and should contains a decimal point before the point integer part, after the point fractional part. 2.3, this is one way of representation. Example, numbers and large numbers, we are using scientific notation also by using exponent e, by using the term exponent e. So before that one mantissa, that is some 2.3 e 10, that is 10 is called power, 10 is called power. If any number is of the form a plus bj, such numbers are called complex numbers. Finally, the last data type we discussed is the Boolean data type. Boolean in the sense a variable can hold only two values, either true or false. The two true or false. These are the contents we had discussed in the last session, right? Now we are moving into this session. The first one is comments. The first one is comments. What do you mean by this comment? Suppose simple thing. Here I am writing a program. If after completion of the program, what is the if you want to know what is the purpose of each line, or in a simple sense, suppose today I written a program, or example after 10 days I saw the program, after 10 days again I will open the program, then how do you identify what is the purpose of this program? It is somewhat difficult. Even if you are writing addition of two numbers program, how can you identify this is addition of two numbers program? Simple thing is you have to move line by line. Okay, we are providing two variables A, B, and we are performing plus operation. Based on that one only, we said this is the addition of two numbers. That means if you want to identify the name of the program, that is what the program do, or not only a program, single line, what is the purpose of this particular in the program? For easy remembering purpose and to easily understanding, we are using the concept of comments. So the main thing is comments are used to explain the Python code. To explain the Python code makes the code more readable to understand. And the most important point of Python is this one. Comments are not executed. What is this executed? For example, here I am writing a program in high level language. Generally, what happens that high level language is converted into mission level language and then perform the execution. But at the time of conversion also, comments are not considered. The comments are only for display purpose. That means no need to follow any syntax rules or semantic rules or logical rules in the comments. You can write anything in any way. You can write anything in any way, whatever the fashion you wish, you can write. The only thing is, so for easy understanding. For example, if I am writing like this is the program to perform addition of two numbers. This is my comment. For example, your comment is addition of two numbers. Whatever the comment you consider, you have to return the comment in such a way that it is easy to understand. Easy to understand. Now, Python, not only Python, generally all the programming languages, we are two types of comments are allowed. Two types of comments. One is single line comment. Second one is the multi-line comment. I think you know that one. You are written the comment in a single line. That means only single line are not executed. Only single line are not executed. Multi-line in the sense you can written the comments in multiple number of lines. Multiple number of lines. Suppose how can you say that this is a comment? This is a normal code. Generally, we are writing the normal code. Whenever a comment occurs, the comment starts with the hash sign. The comment starts with hash sign. So the hash sign is used to represent the comments. All the characters after the hash and the remember this is single line and up to the end of the physical line are part of the comment and Python interpreter ignores them. Okay, single line comments in the sense hash followed by some set of statement, followed by some statement, some concept, but it is only in a single line. For example, if you are moving in the second line, automatically it gives an error. Automatically it gives an error. Now, if you want to write the comments in multiple, for example, see this one example. This is comment. This is my first program, and this is comment. Print message. That means you can write the comment at the top of the program, or you can write the program comment at the right side of the. There is no restrictions on the place. In the simple logic terms, there is no restrictions on the place of the comment. Whenever you require, simply write hash and then single line. Now, multi-line comments. That means if you want to write the comments in multiple number of lines, write the comments in multiple number of lines, then use multi-line comments. For that, we are using triple quotations. You are using triple quotations like this. Okay. Now I will show you the execution, how the comments are running. File, take the new file. For example, first I am writing multi-line comments. Here you are using quotations, either single triple quotations or double triple quotation. Suppose I am writing like this. This is the program to perform addition of two numbers. Close. See this one, this is a comment. This is not executed by the interpreter. So by seeing this one, okay, this is the program to perform addition of two numbers. Or you can write like this also. Program to perform addition of whatever it is. Syntax is not considered. It does not consider the syntax. Okay, simply this is only for user understanding. Now, for example, a is equal to 5, b is equal to 6, c is equal to a plus b. Here, I am writing a comment, perform addition. Okay, what is the step? Then you have to perform by seeing this one. Sorry, this is the comment way. Okay, here in this step, we are performing addition. Suppose next I am printing the value, print C. Suppose here also I can write the comment, okay? Some result is displayed in the screen like this. You got it? So, okay, by seeing the program, this task, this line perform this one, this line perform this one like this. You can write any number of comments in a program. There is no restrictions on the number of lines. There is no restrictions on the number of lines. See this one, the program is executed perfectly, but the comments are not displayed. But the comments are not displayed. That is one of the important point related to comments. Now, now the next one is variables. Variables. So actually we know the concept of variables. How you know means a is equal to 5, b is equal to 6. All those are called generally variables. All those are called generally variables. Simply variable is an identifier. First of all, remember the name. Variable is an identifier. What is the meaning of this one? Whenever you said variable is an identifier, the properties of identifier are applied to variable. That is, we are giving the name of a variable based on rules of the identifier. What are the rules of identifier? An identifier contains the letters A to Z, 0 to 9, and the special symbol underscore. Only these three are allowed. And again, we have a restriction. It does not begin with a digit. It does not begin with a digit. For example, A is an identifier, total is an identifier, sum is identifier. For example, total underscore add. This is also an identifier. How many number of identifiers these are? This is only one. Here we are separating this one underscore only. Suppose if you are separating with a comma, then only these are two identifiers. Originally speaking, these are two variables. This is one variable. This is one variable. This is one variable. Variables, okay? Whenever we are creating a variable in the program, then what happens? Some memory. For example, if I am writing the statement a is equal to 5, where 5 is stored? Where 5 is stored? Simply, we have to assign some memory. We have to create some memory. In that memory location, only the variable is stored. So, variables are nothing but reserved the memory locations to store the values. Whatever the value we are passing, that value are stored in the memory. This means, see this one, the same thing. When you create a variable, you reserve some space. Suppose once you are writing this statement, system, that is a compile interpreter, automatically allocates the memory. Automatically allocates some memory. So Python does not contains any command for declaring. Why? In Python, no need to specify the data type. At the time of declaration only, we are specifying the data type. In Python, no need to write the declaration. Whenever you want a variable, simply use the variable. So that is the thing. Python variables do not need explicit declaration to reserve. The declaration happens automatically when you assign a value to a variable. You got the meaning? Whenever you are assigning a value, automatically the declaration is completed and automatically the memory is assigned. Suppose other languages, first we have to write the statement int a. Whenever you are writing the statement, then only the memory is allocated of size integer. Suppose for integer we have some memory fixed. So that amount of memory is allocated for the variable a. But here Python, there is no concept of declaration. Directly uses. Okay. Now, one of the most important concept related to programming languages. Not only here I am saying not only Python, generally for any programming languages, operators is some part of the programming languages. Why? Even general worst case, if you are performing simple calculation also, we require at least one operation. For example, if you perform addition operation, you require plus symbol. If you want to perform multiplication, you require star symbol, that is into symbol, division slash symbol, like that. Minimum operators are required to perform any small programs. Operator is simply a symbol which is used to perform an operation. What do you mean by operator? For example, operator is a symbol. This is a symbol used to perform an operation. To perform an operation. These are different types of operators available in Python: arithmetic, assignment, comparison, logical, identity, membership, bitwise. Actually, these two operators are not available in C and Java. So, remaining operators are exactly available, but these two are not available. These two are not available. Step by step, we will move to the operator and then we will move to the execution also. First one, the basic operators, that is arithmetic operator. So plus is used to perform addition. Remember the thing, if 2 plus 3, you are performing addition between two integers, 2 plus 3. The answer is 5 only. If both are integers, the result is integer. Suppose 2.3 plus 5.2, the answer is 7.5. If both are real, the answer is real. For example, 2.0 plus 3, the answer is 5.0. One is floating and another one is integer. Obviously, the answer is floating. Here, no need to remember every person, even though whether it is a real, you don't know the concept of integer or floating, we are doing the same operation. Even when mathematical also, we are doing the same operation. That is addition operation. Exactly. Subtraction operation. For example, 2 minus 3, the value is equal to minus 1. Like that, normal mathematical subtraction is performed. Mathematical subtraction is performed. Star is used for multiplication. Star is used for multiplication. Simply 2 into 3, the answer is 6. 2.0 into 3, the answer is 6.0, like this. Okay. These three are not at all important. Why? Because in normal mathematics also we are using the same thing. Here the only thing you have to remember is in normal we are writing 2 into 3 is equal to 6. But in not only Python, in all the programming languages, the multiplication symbol is star. Remember, the multiplication symbol is star. Now, now, these are some different. Before that one, I will explain this one. Double star. If you are using single star, that is called multiplication. If you are using double star, that is called power. For example, 2 double star 3. The meaning of this one is 2 cube. Suppose A double star B. If you have a statement A double star B, it is represented as A power B. That is 2 cube in the sense H. Got it? Now, coming to these three. First, this one. and this one. First, I will explain these two. Slash is called division operator. Double slash is called floor division operator. Whatever it is, simply the symbol for slash is a division operation whenever we are performing division operator between two numbers. The result is quotient. If you are performing division operation, the result is quotient, either single slash or double slash, whatever it is, division, the result is quotient. And percentage, this is the symbol, it is called modulo division. This is called modulo division. The result of the modulo division is remainder. The result of the modulo division is remainder. Okay, now I will explain this one. 5 by 3. How we are performing this operation? 5 is an integer, 3 is an integer. In this one, we are not considering the type. We are not considering the type. So simply 3 divided with 5. For example, consider 2 for simple calculation. 2 divided with 5. That is 5 is divided with 2. Okay, here whatever we are getting, that is my answer. That is my answer. So 2 into 2.5 is equal to 5. The remainder is 0. Here the answer is 2.5. Here the answer is 2.5. Now let's check whether it is right or wrong. I will explain all the operators with execution. For example, first basic operations, 2 plus 3, that is 5. 2.3 plus 5.2, that is 7.4. 2.0 into 6, that is 12.0. 3 minus 2.1, that is 0.9, sorry, 0.899, whatever it is. Coming to division, 5 divided by 2. So what is the result? The result is quotient. What is the answer? Just now we discussed. The answer is 2.5. 2.5. Now, even though both are integers, observe the fact, even though both are integers, the result is in fractional, in normal division. For example, 5 double slash 2. 5 double slash 2. I will explain the meaning and then go on. First, again, 5 by 2. This is divided like this. This one. 2 into 2.55. That is exact multiplication is performed. 5 double slash 2. In this case, it performed like this. 2, 2 jar 4, and the remainder is 1. You got it? It does not consider the floating point value. It performs not exact division, only integer division is allowed. Floor. What is mean by the term floor? Floor is the mathematical term. Remember the term floor. If you are writing floor of 3.4, the answer is 3 only. If you are passing any floating point number, it automatically converts to the nearest integer. Floor of 3.4, the answer is 3. Suppose the floor of 3.9, in this case also the answer is 3. The integer part is only returned. If you are floor operation, it returns only the integer. So 5 to 2 into 2, 4, this is the one. So the answer is the quotient 2. In this case, you are performing 5 modulus 2. So what is modulus? Remainder. So if you are performing modulus operation, by default it performs the floor division. By default it performs the floor division. The answer is 1. Now I will show you. Here lot of things. See this one? The answer is 2 only. 5 mod performing percentage, the answer is remainder. The remainder is 1. Always it performs a floor division. You assume that for this one, if you are performing like this, This is also a possible. This is one possibility. This is another possibility. So what is the what happens when you are writing always remainder as zero? There is no use. That generally that division is the floor division. Why? In the floor division only we got reminders. In the floor division we are getting the reminders. For example, 5.0 by 2, meaning if even though if both are integers, two things you have to remember, and these two are the most important. Even though both are integers, if you are performing single slash operation, is the floating, that is exact division is performed. So if at least one is float, answer is same. If both are integers, in this situation also the answer is float. If at least one is float, in the final worst case the answer is float. That is not a problem. Now 5.0 double slash 2. This is the important thing. This is the important thing. Here 5.0, if both are integers, the answer is an integer only. But if at least one is float, the answer is in float. But here it performs a floating point division only. Now see the answer, not 2.5. Here the answer is 2.0 only. That is what happens. It performs the division like this. 2 2s are 4, 1. It is 2.0 only. Performs the exact multivision and then simply add a decimal point. Suppose you have a doubt. 5.6 is divided with 2. In this case also it is not 2.3. In this case also it is 2.0 only. Okay. So after point, whatever the value we have, simply ignore the value and place it as 0. See, this is 2.0, 5.6 double slash 2. This is also 2.0. You got my point? So in floor division, whatever the fractional part, what do you mean by fractional part? The value that is placed after the decimal point is not considered. See, the answer is 1.0 only. See, here it performs the exact. What is the remainder? So 5.6 is divided with 2. This is the remainder. But the quotient is 2 only. The quotient is 2 only. Got it? This is the arithmetic operators. So again, I am repeating. Why I am repeating this many number of times in the sense, this is the most important thing. The comparison between the division modulo, that is of floor division. So in these two cases, the answer is quotient. So here single slash, this is called float division and this is called floor division. Float in the sense after performing division operation, the result is in floating point. That is, it performs exact division operation. So double slash in the sense it will convert the number into floating floor number and then perform the division. Always the answer is integer. If both are integers, the answer is integer. If at least one is float, the answer is float. But after decimal point, the only value is 0. After decimal point, the only value is 0. Whatever the value we have. So modulus, it is used to get the remainder. It is used to get the remainder percentage. Okay. If you want to get the percentage, actually the system do this task. Actually the system performs this task. Now, arithmetic operators are completed. So whatever we discussed, the same thing here also. Relational operators. Relational operators. So what do you mean by relational? The name specifies we have to check the relation among two operands. Two operand. For example, a plus b. Here plus c is called operator. I think you know the terms. A comma b are called generally that name in the programming language operands. So relational operators are also called as comparison operator, are also called as comparison operator. After performing relational operation among the numbers, the result is, after performing comparison, what is the result? The result is if both are equal, that is it satisfies the condition, the answer is true. If it does not satisfy the condition, the answer is false. Okay, so the result of the relational operation is true or false. So these are the relational operators. Double equal to make the comparison, A double equal to B. If you are writing a statement, assume A is equal to 3, B is equal to 4, C is equal to some 3. If you are writing the statement in the program directly, if A equal to B and then press enter, automatically the result is false. So the A value and B value are not equal. Suppose A is equal to C, the answer is true. The answer is true. So next to A not equal to B, the answer is true or false? Here the answer is true only. Why? We already said that A and B both are not equal. Exactly. A value is 3. A and B both are not equal. The answer is true. A and C, sorry, A not C, A not equal to C. Here in this case, actually A and C are equal, but we are checking not equal to. So in this case, the answer is false. Like this, we will perform remaining A greater than B, B greater than A, whatever it is. You can write like this. If A value is greater than B value, it returns true. A greater than or equal to B. So generally we are writing like this, A greater than B. This symbol is not allowed in programming languages. You know, not only Python. If you want to use greater than or equal to, first write greater than and then equal to. So these are the basic. Comparing variable. After comparison, based on if satisfies, it returns true. If it does not satisfy, it returns false. So the basic thing. Now, logical logical operator. Generally, these logical operators are applied between different expressions. The logical operators are applied between the expressions. We have three logical operators: logical end, logical or, logical not. What is the keyword? End or not. These are the words. Suppose plus two, minus two. So in the previous two operators, we have the symbols, but here not. B, C. Assume these are A greater than B and A greater than C. This is one expression. This is another. So end operation. What is mean by end? It checks the expression. Remember, we have two cases. A and B. Assume not only A and B. If only two variables, we have four possible cases. What are the four possible cases? True, true. The four possible cases are true and true, true, false, false, true, false, false. Suppose if I am given any two numbers to you, that is the two numbers are 0 and 1. So for these two numbers, we have four possible cases. So what are the different combinations? 0, 0, 0, 1, 1, 0, 1, 1. Like this, if you are performing end operation, what is the result? If both are true, the result is true. If both are true, the result is true. End operation. If at least one, T and F, no need to check false. If the first one is, sorry, if the first one is true, so, sorry, this is not wrong. First one is true, you need to check the second one. True and false, the answer is false. Here the first one is false. No need to check the second expression. Why? If both are true, then only the answer is true. If the first one is false, whether the second one is true or false, the answer is obviously false only. Now, what is the result of end operation? If both the arguments are true, then only the result is true. Exactly, OR operation. OR operation in the sense, if at least one argument is true, that means true and true, the answer is true. True and false, the answer is true. False and true, the answer is true. False and false, the answer is false. This is the only false condition. Exactly reverse. In end operation, if both are true, the answer is true. In the remaining all the cases, the answer is false. In OR operation, the answer is true if at least one argument, or in the sense, if both the arguments are false, then the answer is false. In the remaining cases, it is true. Simply, not in the sense, if it is true, convert it to false. If it is false, convert it the reverse thing. Exactly the reverse thing. Okay. Generally, for Boolean type, we discussed the term Boolean. Bool in the sense we have two variables, that is two values, true and false. Generally, false is represented as 0. Suppose we have a situation, there is no need to use the Boolean variable. Whenever we are writing 0, 0 is considered as false. 0 is considered as false, and true is considered as any non-zero number. True is considered as any non-zero number. For example, 5. 5 is a non-zero number. 6. 6 is a non-zero number. Minus 5. Minus 5 is also a non-zero number. No need to depend on the sign. Here the thing is, we have to know whether it is a 0 or non-zero. The only thing is sufficient. Now, next one is bitwise operators. Here we are performing the operation bit by bit. Of this one, I will show the execution for bitwise also. So here, any number I am given, the number is converted into binary. Why? If you are converted into binary format only, we have bits. Then only it is possible to perform the operation. And the important thing is, the bitwise operators applicable only for integers and Boolean types. For floating point, complex numbers, whatever it is. For the remaining data types, it is not applicable. Bitwise operators are applicable only for integers and Boolean. Suppose if you are trying to apply for any other type, for any type, simply it will show an error. Now, assume A is equal to some 7, B is equal to some 3, whatever it is. Here, how do you perform the operation A ampersand B? The symbol is called A ampersand B. This is the end operation between the two numbers. Clearly speaking, bitwise end operation. For example, if you are writing the statement A and B, the result A contains a non-zero number. So this is true. And B contains a non-zero number. This is also true. True and true. The answer is true. You got it? If you are writing, it is the logical operator based on whether it is true or false. Whether it is true or false. We will, result is true. But In bitwise operators, here we are performing the calculations like this. First, A is converted into binary. What is the binary representation for 7? This is the binary representation for 7. How do you know? So binary number is base 2. 1 into 2 power 0 1 plus 1 into 2 power 1 plus 1 into 2 square. Remember, anything perform multiplication. So 1 into 2 power 0, 2 power 1, 2 square, 2 cube, and so on. 2 square in the sense 4, 4 plus 2, 6, 6 plus 1, 2 power 0 is 1. That is simply the answer is 7. And B is equal to the binary representation is 0, 1, 1. Actually, it is 1, 1. But A has 3 digits. That is the reason I am adding one more digit. If left to side, simply all zeros. Left to side, if you have nothing, simply place all zero. Then perform A and B. 1 and 1. So end, whatever, whether it is this symbol or this symbol, end in the sense always if both are true, the answer is true. If at least one is false, the answer is false. 1 and 1. Generally, 1 is represented as true. Any non-zero number, that is 1 is true, 0 is false. 1, 1. Both are ones, this is 1. 1, 1. Both are ones, this is 1. 1, 0. This is 0. Now, this is my answer. Now, how to do? The result is displayed again in decimal format. Convert into decimal. So, how do you convert into decimal? 1 into 2 power 0 plus 1 into 2 power 1. The answer is 3. So, remember here the value is 3. That is the reason the answer is 3. No. So, for this example, it will consider, we got the answer as 3. For this example, there is a probability the answer is 3. So simply what you have to do, perform the calculation and then convert into decimal. Now A or B. How do you calculate A or B? If at least one is true, the result is true. First, 1 and 1, the answer is 1. 1 and 1, the answer is 1. 1, 0, the answer is 1 only. So if one is true, the answer is 1. Here the number is 7. Suppose consider this is my example 101 110 0 0. This is my example. So now how do you perform? That is A value is equal to, how do you calculate? 2 power 0, 2 power 1, 2 square, 2 cube. Simply 8 plus 2, 10. This is the value of 10. This is 2 cube plus 4, 8 plus 4, 12. This is the value of 12. If you perform ampersand, that is addition, end 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1. So, if you are performing end operation, the answer is 8. If you are performing OR operation, see 0, 0, the answer is 0, 1, 0, 1, 0, 1, 1, 1, 1, 1. So, the answer is some 14. You got it? So end operation if both are 1, 1. OR operation if at least 1, 1. Now the last one. Right now we discussed this one and then move to the next session because the time up. A XOR B. XOR B in the if both the bits are 1, if both the bits are 1 or both the bits are 0, the result is 1. The simple sense, if you are performing XOR between two bits, if both the bits are same 1 1, the answer is 0. 0 0, the answer is 0. If bits are different, the answer is 1. What is the XOR? This is 1 1. The answer is 0. This is 1 1. The answer is 0. This is 1 0. The answer is 1. Here you got it. If bits are same, 0. If bits are different, it is 1. Now see this one. 0 0. The answer is 0. 1 0. The answer is 1. 0 1. The answer is 1. 1 1. The answer is 0. 1 1. The answer is 0. This is XOR operation. Okay, we will continue the things in the next session. Okay.